Alrighty, we are going to go ahead and review right triangle trigonometry. So, this is going to be essentially the first of an extensive video series covering all of trig. Pretty much anything you need to know for AP Precalculus for that exam. So we're going to go from right triangle trig to angles in standard position and radians, to the unit circle, to graphing trig functions, to trig identities and solving trig equations. Then we're going to talk a little bit about polar coordinates as well. The first step, though, to build in that journey is ultimately to review this right triangle trigonometry. So this video is really designed for anyone looking to study for the SAT, anyone who is a pre-calculus student, either reviewing for a quiz or test, or just trying to refresh right triangle trigonometry before a lesson, and any other students, honestly, just looking for a quick refresher. So, right triangles, we know, have one angle that's 90 degrees, a right angle. That's where the name comes from. Okay. The side opposite the right angle is going to be called the hypotenuse. That right angle is always going to be the largest angle in a right triangle, and the side opposite the largest angle will always have the longest length. The other two sides are going to be called the legs. So this is just some general terminology here that you should be familiar with. Questions on assessments might use those terms. Now, we come into our trig ratios. So our SOHCAHTOA, that's very likely an acronym you've learned to memorize them. So we have sine. Here, this symbol is called theta, and it's used to represent angles. So, you will be seeing theta a lot more. So we have sine, it's opposite over hypotenuse, that's our SO. Then we have cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So let's put that in practice. Let's let this angle be theta, right here. So sine will be our opposite side over our hypotenuse. Cosine will be our adjacent side over our hypotenuse. And then tangent will be our opposite side over our adjacent side. So you can see those relationships. A few notes. Hypotenuse is always the longest side. Okay, that means that these two cannot ever be greater than 1. Right? We can't have one of the legs be longer than a hypotenuse. That just doesn't make logical sense. Now, it is natural to think right now, well, how could sine or cosine ever equal 1? That doesn't make any logical sense. Once we talk about angles in standard position in the unit circle, it's going to become a little bit more clear that we actually can equal 1. So we'll get to that later. Another note here about right triangles is the Pythagorean theorem works for them. It only works, however, with right triangles. We are going to cover later on, possibly, some methods to solve for non-right triangles, but Pythagorean theorem can only be used with right triangles. Now, sometimes if you have, let's say, an 89-degree angle measure in a triangle, you may be able to just use Pythagorean theorem to approximate a side length, but really, it only fully works for right triangles. Now, we're going to review what solving a triangle looks like. So solving a triangle, once again, just means to find any and all unknowns. So essentially, we need to find side lengths and angle measures, okay? So, generally, there are some steps likely that we're going to use to solve a right triangle. If we are given, let's say, one side or two sides and one or two angles, we could find a trigonometric ratio. Then we can use inverse sine or inverse cosine or inverse tangent, basically our inverse trig functions, to solve for angles. Remember, inverse trig is what gets us angles. And we can also call this, for example, arc sine. We can call this arc cosine. And we can call this arc tangent. So that's how we get our angles. There is only one angle that you can have in a right triangle that will give a certain trig ratio. Once we start to think about triangles in the coordinate plane, that's going to get, again, a little bit more complicated, but for now we don't need to think about that. Then, because we're only talking about right triangles here, we can use Pythagorean theorem to solve for a side length. Then we can use essentially our triangle angle sum theorem. Our triangle angle sum theorem to solve for any unknown angles. We know that all the angles in a triangle sum to 180 degrees. And in a right triangle, right, one of the angles must be 90 degrees, okay? If we know one of the angles has to be 90 degrees, then the sum of the other two has to be 90 because 180 minus 90 equals 90. Final note, big concept here. Special right triangles. So we have our 30, 60, 90, and we have our 45, 45, 90. So first, let's talk about 30, 60, 90. Let's say, hypothetically, we have a 30-degree angle here, a 60-degree angle here, and a right angle here. Let's say that this short leg has length x. Just kind of have to memorize this for now. The long leg will have a length of x root 3, and the hypotenuse will have a length of 2x. Okay? Hypotenuse is double the length of the short leg, and the long leg is root 3 times as long as the short leg. Then we get to our 45, 45, 90 triangle, okay? So, couple notes. Ooh, wow. We have 45 degrees here, okay? 45 degrees here, okay? These two sides, because the angle measures opposite to them are the same, are going to be congruent. Let's say they're both x. Now, let's apply Pythagorean theorem. Let's say this is c. C is the square root of x squared plus x squared. That means that c is the square root of 2x squared. It means that c is equal to the square root of 2 times x squared. That means that c is equal to the square root of x squared times the square root of 2. That means that c is equal to x times root 2, which is equal to x root 2. So, x root 2 is our hypotenuse length. So, given all of this information, it really should just be a review for you. Go ahead and head over to the other video that's going to give an overview of a practice quiz on right triangle trigonometry. Or if you feel like you don't need to do that right now, you can always head over to the next section where we're going to introduce some new trigonometric functions with our reciprocal trig functions.